let's take a look at example 5.17. So it says a light rope is attached to a block with a mass of 4 kilograms that rests on a frictionless horizontal surface, as pictured here. The horizontal rope passes over a frictionless, massless pulley, and a block with a mass M is suspended from the other end. When the blocks are released, the tension in the rope is 10 newtons. Draw a free body diagram, draw a free body diagram, two free body diagrams, one for the 4 kilogram and one for the block with mass M. They also want me to find the acceleration. They also want me to find the mass of the hanging block. And then lastly, how does the tension compare with the mass of the hanging block? All right, so whenever we have multiple masses, the first thing we want to be able to do is we want to identify the direction of acceleration for my two masses. If it's 0, I don't have to worry about it, but if they are going to accelerate, so this is a frictionless surface, so these are definitely going to accelerate that direction, I want to make that my positive direction. That way, when I set up my system of equations, I have these both being positive. So I can say that the A in this equation is the same as the A in this equation because they're both in the positive direction. All right, let's set up our free body diagram. So up here, I have M1G, I have gravity. I also have a normal force acting on it. And then lastly, I have my tension, which they told me was 10 newtons. For this one down here, I have mg, but I also have my 10 Newton tension. Now part D says, how does this weight compare with this 10 newtons? I can already answer that without even having to find this weight. Because it's accelerating down, I already know that this force must be larger than that force. And we will go ahead and show that as well in part D. So now I have my free body diagram, so that was part A. Part B wants me to find the acceleration of either block. So now I'm going to have to generate those equations. So for my 4 kilogram block, so for M1, the sum of the forces in the x direction acting on M1 is going to cause it to accelerate. Fantastic. So I have tension is equal to M1 times A. So I have 10 is equal to 4 times the acceleration. So divided by 4 gives me my acceleration of 2.5 meters per second squared. Because they are connected by the same string, they have to accelerate together as a group. So that acceleration is the same for both. Part C wants me to find the mass of the hanging block. Okay, so now I'm going to need to generate an equation for that. So I'm going to sum up the forces in the y direction, causing M to accelerate. I have down being my positive direction. So I have mg minus 10 equals ma. I need to go ahead and solve for m, so I'm going to have to get them on the same side. So I have mg minus ma equals 10. Factor out an m and divide, so I have m is equal to 10 divided by 9.8 minus 2.5. Plugging that into my calculator, I end up with a mass of 1.37 kilograms. And again, part D wanted us to test that theory. So if I go ahead and put mg, so if I do 1.37 times 9.8, I get 13.4. And that is in newtons, so 13.4 compared to 10, 13.4 is larger. There's your example.